Okay, number 10, or number 4 on problem set 4, part 2, says the 4x6 rectangular grid shown below contains 50 squares. Some are 1x1, some are 2x2, some are 3x3, and some are 4x4. Find 3 rectangular grids, all different, that contain exactly, in my case we're 224 squares. It's actually easier to work with than 70, so I'll use that one. So we're going to have to first figure out how they got 50 squares from this. And if you look, you can have squares that are 1x1. So we can have 4x6 of those. You can have 4 times 6, which is 24. Or 2x2s. On this, you can have a 2, a 2, and a 2. So there are 3 possibilities. And up here, you can have 2. That's 1, 2, 3, 4, 5, 6. Or 4, 5, my bad. So 3 times 5, 15. And for 3x3 squares, you can have 1, 2, 3. That's 1 square and 1 square. So that's 2. And up here you can have 1, 2, 3, 1, 2, 3. So that's 2 total, 3 total, 4 total. And then with the 4x4 square, that's the entire height of this. So you can only have 1 there. And we're going to be able to have 3 here. So you can have 1, 2, 3, 4, 1, 2, 3, 4, or 4 in the middle. So that's the only other 4x4 square you can form. So there's 3 total. So it's 24 plus 15 plus 8 plus 30, which is 50. And that's where they got the total number of squares from. So you can come up with a formula actually to find the total number of squares, where the total equals, for any rectangular grid, let's call this the base over here. And let's call this one the height. So it's the base times the height plus the base minus 1 times the height minus 1 plus the base minus 2 times the height minus 2, so on and so on, to b minus n times h minus n, where b minus n equals 0. Well, technically 1, that'll make it a lot easier to do actually. So if you see, that's the exact form that we used to calculate it here. Base times height, 4 and 6. Base minus 1, base minus 2, base minus 3, and so on and so on. So if we need to find a rectangular grid with a total of 224 squares, well, we can create an equation with algebra. So we can have, let's say the base is 1. Let's say there's just 1 by some really long rectangular grid out that way. So we would have 1 times the height equals 224. The height is 224. So one of the rectangular grids that we could have would be 1, 224. So in length, so the base is 1, and then the height is 224. Or we could have 2 times the height plus 1 times the height minus 1 is 224. Such that 2h plus h minus 1 equals 224, 3h equals 225, h is 75. So another one we could have is 2, 75. We can find a third one by going out even more. 3 times the height plus 2 times the height minus 1 plus 3 times the height minus 2. Plus 1, my bad, times the height minus 2 equals 224. So we can solve this. 3h plus 2h minus 2 plus 2h plus h minus 4, handwriting messing me up there, equals 224. 3 plus 2 is 5, 5 plus 1 is 6, 6h minus 2 minus 4 minus 6 equals 224. 6h equals 230. And h equals 38. So the third one we can have is 3, 38. So those are 3 rectangular grids, all of which will get you 224 total squares. If you want to do it with 70, you can do the same kind of method. Although it's a bit more difficult, you can still have the 1 by 70, but you can't have a 2 or a 3, it's still more difficult. So you'd have to work with your numbers and just guess and check there. But that is the method. I'll write the formula for doing that one more time up on the board. So it's base times the height plus the base minus 1 times the height minus 1 plus the base minus 2 times the height minus 2 and so on up until the base minus some number n is going to be equal to 1. So b minus n, h minus n, where b minus n equals 1. Thank you. I'll give you a second to keep looking at that for a minute, but thanks for watching.